Hi everyone, welcome to STEMzebra. My name is Tejas Rakshay. Today we're going to talk about units of quantities in physics, SI system for measurement, and unit conversion. This is a really important topic if you're going to study physics. I have seen a lot of students in the past who studying high school physics who didn't pay perhaps that much attention to the earlier topics like units and conversion. But later on, they realize that they have a lot of trouble when it comes to either solving homework problems or in exams. So pay close attention to this topic. This is a no math introduction, which means that we're going to just talk about what it means, what the big picture is without using any math. Hopefully, it'll make it easier for you to understand it. Then later on in the follow up session, we're going to do the theory and problem solving. So let's get started. In science, not just in physics, but in any science, you talk about quantities of things, right? You do measurements. There are always measurements in science. So you talk about quantities, but also in real life, you talk a lot about physical quantities. So let's try to understand what are some of the most fundamental quantities you talk about. So ask yourself, what is it, what type of quantity do you talk about most frequently in your daily life? I'll tell you what I talk about most. Time. You talk about, you say, I'll do this in 5 minutes. You say, uh, my birthday is in 2 months. You say, so somebody is, so many years old. You say, uh, I'm going to be gone for an hour, right? Time is kind of essential for everyday life, so much so that you don't even realize when you talk about it that you're talking about a specific quantity called time. So it's ubiquitous. So I would say time is something I talk about more frequently. A lot of people probably do. So it's really a fundamental quantity in daily life and in physics. What else? What other type of quantities do you talk about? Uh, Here's one: distance, right? You talk about how tall you are. You talk about, this town is so many miles or so many kilometers away from that town, or you're using a navigation while driving, or your parents are using it, and they say, I need to drive for 5 miles to get to some place. So distance becomes a very common quantity as well. Of course, now in the days of coronavirus, you have to maintain 6 feet distance, right? That's a distance quantity. What else? People talk about mass quite a bit, and commonly they call it weight. So here um, I have a weight scale, right? Or some people have, weight scale. This is one for food items, right? So it's a small one, but you can measure. In physics, it's called mass. We will talk about the difference in a little bit, but commonly people call it a weight, right? 100 gram of something, or 1 pound, or kilogram, or something like that. People stand on bigger scales and weigh themselves. Where else do you see mass? By the way, can you think about it? When I go to a grocery store, a lot of things have masses or weights written on them, right? So I have a few examples here I'm going to try to show. some of these examples. Here, I have a Cadbury Dairy Milk chocolate bar. I'm not advertising, by the way, for any of these things, okay? This is just something I found. It's in my pantry. All right, can you see what it says here? See what it says? Net weight, WT for weight, 3.5 ounce, 99 gram. So I'm going to try to focus this a little bit more. I feel like it's a little bit out of focus. I'll give it a second. That's better. Okay. So it says net weight is 3.5 ounce, which is equal to 99 grams. So whether you use ounce or gram, you can use either one. Uh, it says it has 4.5 gram of saturated fat, 30 milligram of sodium, uh, 17 gram of total sugar, right? These are all mass quantities, or they're called weight quantities. How about this? Another food item. Again, I'm not advertising for this, but it says that the weight is written here, net weight 1.5, 1.4 ounce, 40 gram, and it has 8 gram of protein. So in a grocery store, a lot of these things have the weight or mass written on them. Um, what else? Can you think about something? So we talked about three things, right? What did we say? Time, right? I said time is a fundamentally important thing. Time, length or distance or length, and mass, or commonly known as weight, right? Time, length, mass. What else? You have a thermometer at home. You measure temperature, right? So temperature is also a fundamental quantity, right? Temperature. Okay, now think about what else do you measure? Do you measure volume or, like size of things? How about that? So I got something here, right? Another food item. Unfortunately, that's all I could find, for example. So here it is. It's a um, sorry, milk carton. And let's see what it says here. I'm going to autofocus once again just to, it's a different depth, so the camera has to focus a little bit. So it says it's a half gallon or 1.89 liter. So then is volume also a fundamental quantity? Would you say that? Now, earlier we said length is a fundamental quantity. But remember that volume is nothing but length in three-dimensional. So you can obtain volume by using length. You can say I have, let's say, a container of size, this much distance by that much distance by that much distance, a three-dimensional box, a container, and that defines the volume. So if you define length as a fundamental quantity, then you don't need to use volume as a separate fundamental quantity. It can be gotten from the length. So length, time, mass, temperature. There are a couple of other ones, and we're not going to talk in detail about that. One other quantity that you might see, at least written here and there, is current, amps. You'll find different appliances in your house, or some wires or something that'll have like amps written on them. Sometimes a USB charger that you use for phone, it'll have like 2 amp or 4 amp, something like that. I don't remember exactly. So that becomes a fundamental unit. So there are these quantities everywhere, all around you. And interestingly, these are the same thing that are used in science or physics, right? But maybe they're used, like they're combined in a slightly different way to describe more complex things. But at the foundation of it, it's it's still the same type of quantities. So you need to understand how these quantities combine to make various things in physics. For example, have you heard the term like kilowatt, right, for power? Or if you buy a light bulb, it will say watt or something like that. Um, or sometimes they talk about like car engines, horsepower. So what is watt or horsepower or some of these other things? They are derived from these fundamental quantities. So once you define a set of fundamental quantities in physics, you can obtain these other derived quantities. So now hopefully you get the idea what kind of quantities are used in physics or science or daily life. But what about the units, right? I call this units of quantities. So what's a unit? Well, you've been talking about units all this time, right? I showed you this bar. Uh, Hopefully, all this food talk is not making you hungry. If you can always pause the video, grab a snack. I showed you this, and I said it says 8 grams of protein, right? 8 grams of protein. So the gram is the unit. It says here 1.4 ounce, OZ for ounce, uh, or the same 40 gram. So here gram is the unit, here ounce is the unit. Now, if you're watching this video from a country that doesn't use ounce, you might get confused what ounce is. And I can totally understand that because not everybody uses the term ounce, but uh, here in the US it's used. So it says ounce here. Similarly, I showed you this milk carton example, right? I'm going to show you one more time. So it says half gallon or 1.89 liter. So gallon is a unit. Liter is a unit as well, right? Just two different units used to describe the same quantity. Same thing with the chocolate. If you're not, if that's making you hungry, I'll skip the chocolate. Uh, I showed you this for distance, right? I showed you this for distance. So this is an inch side of the tape, and if you flip it, you actually there's also inch and centimeter and millimeter here. So there these two things. They both measure distance, right? But they're two different units, inch and centimeter or millimeter for that matter. Uh, How about time? What kind of different units do you use for time? Here uh, I have a timer here, right? What is it measuring? It's measuring seconds, right? But you don't always talk about just seconds, right? If I ask you how old you are, you're not gonna give me the answer in terms of seconds, right? You're gonna say years, or for a small baby, you might say, 4 months, right? It's a different unit. Second is a unit. Second is a unit. Months, years, they're different units all of time. How about weeks, days, right? They're all units of time. So unit uh, units are used to conveniently represent these quantities. In again, in daily life or in science, in physics, it's the same principle. But if you're going to study physics, you have to understand what they mean. You need to understand how to use them correctly, how to translate one from the other. And if you combine them in strange ways, they can get kind of complicated a little bit. So you need to really pay attention to this the how pay attention to how to convert units and how to use them correctly. Okay, so we talked about what the units, what quantities are and what units are. What is this next thing? SI system. What is SI system? It's actually quite important. This is specifically for physics. It's really important. SI system. The term SI stands for system. Well, it's a French word, but it's international system of measurements. or units. So scientists or international coalition of scientists has agreed to use certain set of units to represent scientific quantities. Now, let's say we were talking about, I'll give you an example, inch and centimeter. I'll tell you one thing. So I grew up in India, and we always use kilometer and liter. So uh, you talk about like a car mileage, right, or gas efficiency. You talk about, we used to talk about kilometers per liter. So I came to the US for graduate school, and everything was different. And I had no idea what a mile was. I had absolutely no idea what a gallon was. I'd never even heard of. I probably had heard of the word gallon somewhere, but I have no clue. It's like 100 liter or 1,000 liter or half a liter, no idea whatsoever. So the first I heard about miles per gallon, I just couldn't translate it in terms of something I knew, right? What is miles per gallon compared to liter per kilometer? So it takes some time for the new system to sink in. So it's not just about one unit. It's about a whole system. So if, let's say in science, if everybody starts using different systems of their own, it'll become very difficult for scientific papers or scientific notation, or when people express these things, it'll become very confusing. Another thing will become really confusing, which is there is a set of important constants. These are the constant numbers, and you haven't studied them yet, but as we go along, you'll study them. Something like gravitational constant, for example, or permittivity of free space. You don't probably know what that means yet if you're watching this video, but we will talk about it in one of the later videos at some point when we're studying like electric fields and stuff like that. So all these constants, they depend on the system of measurements. Like if you're using kilogram and meter, that's one thing. But if you're using pound and yard, or like something like that, it becomes the units, the numbers change of those constants. Like gravitational constant will be at one number in one system, a different number in different system. So it'll become extremely confusing. That's why scientists have agreed to use a consistent system, and that's called the SI system. Almost all of the textbooks, modern textbooks, or pretty much all of the textbooks use SI system in physics. So it's quite possible that your whatever textbook you're using is also an SI system. Of course, talk to a teacher, make sure that that's what they want you to use. Uh, but so it's very important for you to know what SI system is. An SI system is kind of intuitive. I would say it's probably one of the simplest systems to learn, much simpler than, miles and gallons. So, what is the SI system? I'll write it down. So the SI system has some things that you have heard of. Almost all of them, I'm sure you have heard of. For example, for time, we use seconds in SI system. For length, we use meter. For mass or weight, we use kilogram. For temperature, this becomes a little bit tricky. For temperature, we use something called a Kelvin. And you probably don't know what a Kelvin is yet. You're used to Celsius or Fahrenheit, right? If you're if you're in the US, you use Fahrenheit to say today is really hot, it's 100 degree, right? Or Fahrenheit is very common when it comes to human temperature measurement. If you're in another country, maybe use Celsius to say it's 40 degrees Celsius is really hot or something like that. But Kelvin is something completely different. We're not going to talk about that just yet because it'll be confusing. But these are some quantities that these are some units that I'm sure you have heard before. Excuse me. Uh, and there are other ones too, like current is amps, right? Ampere, but amp. I'm sure you have heard about this as well. If you check, your appliances, you'll see something like amps written. So this is the system that's called SI system. Okay, well, what happens when the quantities are much bigger, right? Like or much smaller. Like if you're talking about tiny quantity of mass, can you really use kilogram? Is that feasible? Probably not. So to represent these quantities that are much smaller than, let's say, a kilogram, uh, the the system used there is called metric system. So that means tens, like powers of 10. So now remember, this is a no math introduction, so I'm not going to go in detail. But instead of kilogram, you can use gram, milligram, right, microgram. The same way on this measuring tape that I had somewhere here, there's centimeter. So in this case, the inch is not a part of SI system. The centimeter is, right, because it's a you know it's based on meter. So meter, then there's centimeter, there's millimeter. If you go even smaller, there's micron and nanometer, etc. So all that is a part of metric system. So in other words, uh, you can you can convert the SI system, the base units of the SI system, to measure something much bigger or much smaller as well using the metric conversion. Okay, so we have talked about the SI system briefly. Hopefully, you kind of get an idea what that is. Uh, One really important thing that you will need to study, and we're going to solve problems just so you understand really how it works, is unit conversion. Uh, a lot of students I've seen, they have problems converting units because it gets a little bit confusing. And when it's unit conversion, what uh, pops in your head? Like, are you thinking about a gallons to liter type of conversion? Yeah, that kind of conversion is something you might have to do in a physics problem. But sometimes it's even within the metric system. I'm sorry, even within the SI system. Let's say that you're given multiple quantities. Say one is in milligram, the other one is in kilogram, or distances. One is in centimeter, the other one is in meter. You have to know how to convert them. Let's say that I told you that uh, I have a tree, a plant that's 1 meter tall, 1 meter. And then I said, in last 1 month, it grew by 3 centimeters. So how tall is it now? So it was 1 meter and then it grew 3 centimeters. Can you just add one and three? 4. Is that the answer? No, right? Because centimeter is much smaller than meter. So you need to add units or to combine different units. You need to convert them to the exact same system. So you need to be able to either convert that centimeter to meter or centimeter and then add them together. Now, it kind of sounds simple when I say it this way, but there are things in physics that involve a lot of different types of units, right? Like time and distance and things that involve like energy or power or current. All these things can get pretty mixed up. So you need to be able to convert one set of you, you did multiple quantities into a consistent system that you can use to add, subtract, multiply, whatever you're doing with it. Okay. And the good thing is that Once you understand it and if practice a few times, it'll become, fairly intuitive and obvious. And even later in life, you can use this quite a bit, right? Even in your professional career, someday you'll encounter things that the that uses different units, and you need to be able to compare them to each other, or add or subtract them. And in that case, it'll be really handy for you to learn how to do that conversion. Same thing, actually, it's the same idea the way it's currency conversion works, right? If you have different currencies, then like if you have dollar and Japanese yen, you need to understand how they compare with each other, right? If you go to Japan one day and you want to convert your money to yen, you kind of need to understand how that conversion works. It's the same idea. So uh, today we learned about the units of quantities. So I'll just flash it here real quick. We learned about what quantities are, and what the units are. We learned about what the SI system means, and we just briefly talked about why unit conversion is important. So next lesson, we're going to talk about the theory of some of these. Okay, so that's all I have for now. Thank you for watching. I'll talk to you next time.